Welcome back. Today, we join two builders turning an empty patch of forest into a permanent winter shelter. The work begins below grade. Excavating a deep trench creates a thermal sink, using the Earth's stable temperature to insulate the eventual cabin. Hours of hand digging strip away the organic topsoil down to dense clay. This heavy subsoil lacks the aerated structure of the forest floor, making it a highly stable foundation that resists shifting under the massive weight of timber. Caloric burn in this environment outpaces normal labor. Hot meals provide the immediate thermal energy required to keep muscles firing in the damp cold. Raw timber must be processed immediately. Felled wood holds immense moisture, making it heavy and prone to warping if left untouched. By bucking and sinking the primary posts now, they lock the structural footprint in place. The first uprights establish the grid. Every subsequent load-bearing joint relies on these initial pillars standing perfectly plumb. A shelter's longevity is dictated by its drainage. Scraping the trench floor perfectly flat eliminates low spots where groundwater could pool and rot the wooden base. Pushing the earthwork wider creates necessary clearance for the outer walls. The surrounding earth will eventually pack against the timber shell, serving as a massive natural windbreak. Working the damp red clay requires constant edge control. Shaving the surface rather than digging prevents disturbing the compacted layers beneath. The smooth floor is essential. a continuous supply of dimensional lumber is pulled straight from the surrounding canopy. Selecting straight-grain timber ensures predictable load distribution once the logs are stacked laterally in the trench. Placing structural posts directly into the fire is an ancient preservation technique. The intense heat alters the cellular structure of the wood, rendering it highly resistant to rot and insects. The thick layer of carbonized char acts as a permanent, waterproof shield for wood buried directly in the wet earth. Chainsaw notching creates a mechanical saddle for the crossbeams. Gravity alone will lock these joints together. Dropping the primary span into place defines the roofline. Minor imperfections in the log's diameter are quickly leveled out with the saw, ensuring the top plate remains perfectly horizontal to support the coming rafters. Raw timber frames require custom fitting at every intersection. A hand axe shaves away the high points of the sapwood, marrying the uneven surfaces into a tight, friction-fit bond. Flush alignment here prevents downward forces from shearing the vertical posts. The skeleton can now carry serious weight. A synthetic barrier is the first defense against rainfall, protecting the exposed clay floor while the exterior shell is assembled. Enclosing the dugout requires dozens of thick, insulating logs. The bark is left intact to provide a rugged primary layer of thermal resistance against the coming frost. Inside, milled boards line the earth walls. This interior cladding prevents the trench sides from collapsing inward as the soil dries and loses its cohesive strength. A reflective vapor barrier stops subterranean moisture from leaching into the living space. It also reflects radiant heat back into the cabin. Heavy nails anchor the top courses of timber, binding the roof rafters to the wall plates. The continuous green tarp completes the dry envelope, shedding water away from the foundation perimeter. Even microscopic gaps bleed heat. Packing fibrous insulation between the logs eliminates drafts and breaks the thermal bridge. Modern screws provide shear strength where wooden pegs would snap under settling pressure. Shaping the overhangs with an axe ensures water drips free rather than wicking back into the end grain. Transporting raw materials by hand through dense brush demands brutal endurance. Every plank represents hundreds of calories burned before a single cut is made. A steep perimeter trench acts as a dry moat. It intercepts ground runoff during heavy storms, routing waters safely around the sunken walls. Trimming the rafter tails flush creates a clean fascia line, preparing the edge for the final roof capping. Creating a blunt edge along the roofline prevents wind from catching the overhang and lifting the tarp. With the structural shell capped, focus moves to fortifying the barrier against the rapidly dropping temperatures. Securing a plastic skirt over the trench lip prevents earth movement from spilling debris into the wall cavity. Natural jute fiber is unrolled along the joints. Its dense weave compresses under the weight of the logs, forming a gasket-tight seal against the wind. Wooden wedges are driven into the irregular seams. This chinking technique locks the horizontal timbers under constant tension, preventing them from twisting as the green wood dries. The final upper courses bear the direct weight of the roof load. Proper alignment here ensures the compressive forces travel straight down to the charred foundation. Precision joinery at the corners is the hallmark of a stable cabin. Scoring the cut with an axe before notching prevents the chainsaw teeth from tearing the outer fibers. The resulting interlocking joint is rigid enough to withstand lateral shifting without relying heavily on metal fasteners. As winter sets in, survival depends on thermal mass. Burying the synthetic roof in heavy earth creates a thick insulating blanket, trapping the eventual heat inside while defending against the sub-zero air. The frozen soil is unyielding, making the final roof loading a brutal race against the weather. Capping the perimeter locks the dirt layer securely behind a wooden retaining wall. Inside, the raw earth floor is violently uneven. Shaving it flat allows for the proper installation of a rigid wooden deck, isolating the inhabitants from the freezing ground. The heat source is the heart of the system. Stacking wooden rounds creates a stable, elevated plinth, keeping the hot metal off the combustible floor layout. The stove must be perfectly level to draft properly. Any tilt could cause smoke to backflow into the living space. Punching through the thick log wall requires plunging the chainsaw bar directly into the timber, hollowing out a precise exit for the exhaust pipe. Metal flashing seals the exterior gap, expanding and contracting with temperature swings, to prevent snowmelt from leaking down the chimney. The first spark changes everything. The cold dugout becomes a sanctuary. With the interior heated, fine carpentry can continue late into the night. Hand chiseling deep grooves requires sharp tools and patience, carving out tight mortises that will hold the interior framing without excessive hardware. Adding finished panels around the entrance tightens the air seal, guarding against the fierce winter drafts. A laser level dictates absolute precision in the chaotic, organic space. Marking a flawless horizontal line across the logs ensures the coming floor joists will lay perfectly flat. The massive charred joist acts as the structural spine, distributing the weight of the floor across the subsoil. Hand planing removes the mill marks and splinters, leaving a smooth surface suited for daily living. Using a contour gauge allows the builders to scribe the exact profile of the raw log pillars, transferring the chaotic shape onto the clean floorboards. Tamping the earth between the sleepers reduces moisture pockets. Once the subfloor is stable, the scribed boards are notched and driven tightly into place. Wedging the gaps forces the wood fibers together, eliminating floor squeaks caused by seasonal expansion and contraction. Continual planing on site guarantees that variations in plank thickness are blended out seamlessly. A flush deck is essential in a small space. The final boards require exact square cuts to lock the perimeter. Driving the last fasteners ties the entire floating deck into one cohesive diaphragm, firm underfoot. Outside, furniture construction begins. Cutting soft curves with a jigsaw softens the brutalist geometry of the cabin, making the interior elements safer and more comfortable to navigate. By deep winter, the landscape is locked in ice. The cabin now functions as a true refuge. Bringing the work indoors signifies the transition from survival engineering to creating a livable home, right down to preparing a warm bed for the dog. Creating strong furniture from dimensional lumber relies on half-lap joints. By chiseling away exactly half the thickness of each board, the intersecting pieces overlap perfectly, resting flush without twisting under a heavy load. Heavy screws permanently anchor the table frame. A solid workstation is crucial for food preparation. The sleeping platform must integrate seamlessly into the organic log walls. Scribing the exact bark contours ensures the frame rests tight against the timber, maximizing the limited floor plan. Elevating the bed captures the warmer air circulating near the ceiling and provides vital storage space underneath. Wide pine planks form a supportive, breathable base for a mattress. The kitchen counterbase is clad in pine, concealing the structural supports and protecting stored provisions from dust. Mounting hardware in such tight quarters demands patience. The hinges are fastened to the frame first, turning raw boards into functional, swinging cabinet doors. A hidden internal shelf doubles the storage capacity, keeping the small workspace organized and efficient. The dugout is complete. In the end, structure, landscape, and daily routine